Section 11.1, page 176177 deals with the volume of a cuboid. Very basic stuff, grade E stroke D in some places. So look at the first one. Find the volume of each of the following cuboids and state the units of each answer. Well, list them. This one's been broken up into little centimetre cubes for us, but essentially we've got 5 times 2 times 2. I'll just write it just here. 5 times 2 times 2. That will give us 10 times 2, 20 centimetre cube of volume. Yeah, I'm sure we can count these. 4, 5, 6, 7, 8, 9, 10, and there's 10 at the back as well. That makes 20. Right? Let's do B then. We've got no mixed units, everything's in centimetres. So we go 4 by 8 by 3, width, length, height, call it what you will. Either way, it's these three lengths multiplied that make a volume. 32 times 3, quickly grab the machine. 4 times 8 times 3, yeah, 96 centimetres cubed. Please note, cubed for 3 dimensions. A centimetre single length, a centimetre single length, another centimetre single length. If you multiply centimetres by centimetres by centimetres, it's centimetres to the power of 3. That's why it's centimetres cubed. C is very straightforward. There's no mixed units, it's all in metres. So essentially the volume is going to be like A and B. It's going to be 7.5 metres by 4 metres by 3.2 metres. Of course, it makes no difference in which order you multiply these lengths. So 7.5 times 4 times 3.2, that gives me 96 metres cubed. And we'll do the last one there. We have a mixed unit. We have 18 millimetres, 5.5 millimetres, and 2.2 centimetres. Well, that equals 22 millimetres. Just multiply by 10 there. Move the decimal point along, and now we have units that are consistent. So here we go. The volume for part D is going to be 5.5 by 18 by 22 and not 2.2. In order to be consistent, we've got the answer in millimetre cubed. Alright, so here I go. 5.5, 18, and times that by 22. That will give us 2,178 millimetres cubed, and that's up to grade, what's that? No, E actually. Here's the grade D stuff. Now look, question 5 says convert the following areas to square centimetres. Now let's just talk about square metres and square centimetres. Here is a square metre. It's 1 metre times 1 metre, and that gives me 1 metre squared, because 1 times 1 is 1. Now that's exactly the same as putting it into centimetres. Now you know a metre is 100 centimetres, and this metre is also 100 centimetres, and we've got an area of 100 centimetres by 100 centimetres, and 100 times 100 is 10,000 centimetres squared. So what have I got? 1 metre square is exactly the same as 10,000 centimetre squares. So how do I change metres square into centimetre squares? I multiply by 10,000. That's all I have to do. So let's just pick one of them. This would be 9 times 10,000, which would be 90,000 centimetres squared. This one would be 4.6 times 10,000. That will give us 46,000, I believe. Yes, 46,000 centimetres squared. What else have I got here? This one's going to be 0.5 times 10,000, and that's going to be 5,000 centimetres square. Is that okay? Now we can go the other way. If going from metre squares to centimetre squares you multiply by 10,000, you can go the other way and divide by 10,000. So let's put here divide by 10,000. So let's just do B1 over here. I've got that divided by 10,000. 1, 2, 3, 4, 1, 2, 3, 4. Well, that's going to give us 30 meter squares. Divide this by 10,000. Divide 1, 2, 3, 1, 2, 3. I can see that 7.5 divided by 10 is 75 divided by 10 is 7.5 meter squares. He's happy. Divide this one by 10,000. 1, 2, 1, 2. Dividing 576 by 100. Take decimal point back twice. 5.76 meter squares. Divide this one by 10,000. I can go 1, 2, 1, 2. 85%, 85 over 100 if you will. That's going to be 0.85 meter square. Alright, so a little bit more tricky, that one. That's grade D rated. I probably have time to do question 6, I think, and maybe break up the videos a bit. Right, here we go. Find the volume of these solids. Now these are solid shapes, and I recommend that you break it down the middle. So you've got a little cuboid there and a big cuboid at the back. Well, if that's 3, so is that. If that's 3 and that's 2, that little part is 2, which makes this 5, because 3 plus 2 is 5. If this is 2 across there going into the screen, then this is also going to be 2, and that one. So I'm going to put a 2 just there as well. So volume of this front part here on the left side is going to be 5 by 2 by 2, using that, and that. 5 times 2 times 2 is 20 centimeters cubed for that part. And this part here, well, what have we got? We got a length of 2 across the bottom and length of 2 there. And if the whole thing is 4, then this must be 2, because 2 times 2 plus 2 is 4. So I've got a 2 by 2 by 2 block. Alright, 2 times 2 times 2. That part is a cube. That's 8 centimeters cubed. So total volume is going to be 20 plus 8 equals 28 centimeters cubed. Do the same for this one as well. Just cut it across there. So we've got a block underneath and a big block on top. So what have we got? If that's 2 and that's 2, that's 2 as well, isn't it? And if it's 6 right across there, is 6 on this side as well, to match the one on the back. 2 plus 2, and if that's 6, that remaining part must be 2 as well, just to give us some more information. Right, what have we got in terms of heights? We've got 6 across there, 2 across there, and what about the height of that little bit there? How big's that going to be? Doesn't tell us, does it? Let's just check it again. It goes 2 deep by 6 across. That's very troublesome indeed. I have to assume that's going to be the same as that one across there. I'm going to call that 2 centimeters. It could be a mistake in the diagram, because I've got no indication that it is in fact 2 centimeters tall, that bit. I know it's 2 across there. It's obvious because it's 2 across there. Maybe they meant that to be 2 centimeters in height. Without that information, I simply can't do the calculation at all. Anyway, I've got a height of 4 and a width of 2, and it goes in 2 centimeters. So that 2 matches that 2, that matches all the 2's. Alright, so I've got basically a little cuboid that does that, and then goes back to the corner from which it came. There you go. That's what I've got effectively, and I've got this other one sitting underneath it like that. Quite tough to draw. Okay, so that's basically what I've got. Not brilliantly drawn, but I'm sure you understand it. Bottom bit and the top bit. Let's just do the top bit. So the top bit is going to be 6 by 2 by 2. I have no choice but to call it 2. 6 times 2 times 2. That's going to be 24 centimeter squares. And the bottom chunk, 4 by 2, and it goes in 2 deep. So 4 times 2 times 2. That gives me 8. Double up, 16. Centimeter cubed. Let me just write down the total volume. It's going to be 24 and 16. That's going to be 40 centimeter cubed. And I sort of finish that off there like that. I think that's okay. I'll stop because we've got a couple of complicated questions later.